right, so we're going to try a more complex problem and break it up into multiple fractions here. So if you notice this problem number 183, it's already got the denominator as a product of different things. So our first product is x, our next product is x plus 1, and finally x plus 2. So this is going to equal some value a over x plus some value, I'm going to call it b over x plus 1, and plus some value c over x plus 2. And if you want to use a1, a2, a3, that's fine. I typically prefer a, b, c, d, and so forth. But again, that's up to you. So our first step will be the same first step as before once we have this equation. And that's going to be, we're going to multiply by what's down here. We're going to multiply each side. Of the equation by x times x plus 1 times x plus 2. Now what that's going to do is it's going to immediately cancel out what's in the denominator on the left. So this part is just x squared plus 1. That's all that's left. And then when I multiply a over x times this, just the x's get canceled, so I'm left with a times x plus 1 times x plus 2. When I multiply it by the second fraction, it's going to be b times x plus 2, because only the x plus 1 gets canceled, because that's what's in the denominator for that one. And finally, c times x plus 1, because x plus 2 is in the denominator. I'm going to make up one more step here before we continue. I'm going to leave the a, b, and c out on the sides of these, but I'm going to distribute everything else. So a times, when I FOIL this, I get x squared plus 3x plus 2. This one I just distribute the x, so it's b times the quantity x squared plus 2x. And similar, this is c times the quantity x squared plus x. So in the previous problem, I had also distributed the a, b, and c, and then set these apart by, what would be x squared, and factor that out. But if you look here, I've got a times x squared, looking at this, and I've got 1x squared here. I've got b times x squared, and I've got c times x squared. So because of that, what we have is we have 1x squared. So that means we need a plus b plus c to equal 1, since we have 1x squared. I know there's no 1 written in front of there, but there's one of them. So, and there's no coefficients in front of those x squared, so nothing else had to be done. If, say, there was say over here, say if this was a 2 in front of where I've highlighted, say if there was a 2 in front of that, well, that would just be 2b. Okay? Need that. Oh, and I lost everything. Wow. There we go. Okay. We're going to do the same thing. We have no x, so when I multiply a, I have 3ax, so that means 3a, b times 2x plus 2b, c times 1x is plus c is going to equal 0, since there are, or I guess there is, no x in the left equation, left hand side. Okay. And finally, we've got this 1 here. So we look at the coefficients, a times 2. So 2a. B, there is no coefficient, and C, there is no coefficient. Just 2a equals 1. And this one is, since there is 1 on the left-hand side. So now we have a system of equations that we can solve. Let's do this here. Well, first of all, this bottom one. This bottom one is simply, we have 2a equaling 1, and this means that a equals 1/2. Divide each side by 2, and we get a equals 1/2. And then I'm going to choose the easier. I'm going to do substitution here. I'm going to choose the easier of the two first. So let's mark this as 1. Let's mark this as 2. Let's mark this as 3. So this is using 3. So let's use 1 now. Use 1 and substitute that 1/2 in. So we have 1/2, because that's what a is, plus b plus c equals 1, which is the same thing as saying b plus c equals 1/2. And then using 2, equation 2, we have 3/2 a, right? Well, actually, a is the half, so I don't need the a. So 3 times 1/2 is 3/2. That's what our a is. Plus 2b plus c equals 0. Well, that means if I subtract 3/2 from each side, I'm left with 2b plus c equals negative 3/2. And let's call these over here equation 4 and equation 5. So if I look here, I can do substitution, I can do elimination. I'm going to just do elimination here. And I'm going to subtract this whole thing. So I'm going to multiply each of these by -1. And that gives me negative b plus 2b, which gives me positive b. And negative c plus c is plus 0. And then I have a negative 1/2 plus a negative 3/2, which will be equal to -2. Okay, so in this case, we have b equals -2. And now we can plug in that -2 back into 4. I have -2 plus c equals 1/2. That means c, if we add 2, that gives us, what, 5/2? So those are the 3 different values. So now we need to figure out what we have here. So we have a is 1/2, b is -2, and c is 5/2. So let's rewrite this down below here. So ax b over x1 and our whole thing was x squared plus 1. We had x plus 1, and then x plus 2. This is what we're trying to find out. And we have the b and the c here. We also note from above a was equal to, what was it, 1/2? 1/2. So we plug in 1/2 for a, so that means it's 1 over 2x, because 1/2 the numerator just drops the denominator. I can do plus, or let's keep it. So if that's going to be -2, I can just make it negative here, or you can do plus -2. That's fine. So that's 2 over x plus 1, and c is 5/2, so plus 5 over 2 times the quantity x plus 2. And that's another way to write this same thing. So if you came through and decided that you wanted to mash all these three different fractions up into one, you would get what's on the left-hand side of the equation. And now each of these things are, you'll be able to take the integral of when the time comes, and that should be our next video.